Good day everyone, we are Group Bio Silpro and today we will be presenting our project titled Biomass to Silica Process Innovation, focusing on sustainable silica extraction from black rice as ash. Our team members are Chong, Dr. Norina, Associate Professor Dr. Faizul, Encik Wan Muhammad Arif, Encik Ruhidin, Muhammad Zaki, and Encik Murizam Darus, followed by Nisha Radhakrishnan. Our presentation will cover the introduction and research background, problem statement and objective, scope of study, literature review methodology, expected outcomes, and finally the conclusion. Research background. Black rice as ash is a byproduct of rice as combustion. It also contains a amount of silica which can be extracted and used in industrial application. However, residual carbon in BRHA reduces the efficiency of silica extraction. Therefore, sustainable and low energy processes like sol gel method are being studied to recover high purity silica effectively. The problem statement which is the residual carbon BRHA interferes with the chemical reaction during silica extraction, which leads to low yield and poor purity. Conventional methods like high temperature calcination are energy intensive and can cause silica to crystallize, making it unsuitable for producing amorphous high purity silica. Our study focuses on addressing this issue through an optimized chemical extraction process. The main objectives of our research are to determine the optimal sodium hydroxide to BRHA ratio for effective carbon removal, to develop the sol gel technique, optimizing parameters such as acid concentration and pH for silica synthesis. Thirdly, to characterize the extracted silica in terms of composition, purity, morphology, and particle size. The scope of study, our research involved in three main stages. Preparation of BRHA, which have to be sieved below 75 micrometer. Chemical treatment, BRHA is treated with 1 mole of sodium hydroxide at 100 degrees Celsius, followed by acid precipitation using 1 mole of hydrochloric acid at pH 9. The characterization was using a XRD, SEM, XRF, and PSA to analyze the extracted silica and recovered carbon. The literature review of black rice as ash. Malaysia generates over 1.2 million tons of agricultural waste annually, including rice husk. When burnt, rice husk produces black rice as ash, which is rich in silica but contaminated with carbon. Studies shows that BRHA can contain up to 80 to 90 silicon oxide, which is making it a promising source for sustainable silica recovery. Silica in BRHA dissolved using a sodium hydroxide to form sodium silicate solution at around 100 degrees. This method is low energy, environmentally friendly, and preserves the amorphous structure of the silica. Then the hydrochloric acid is added to precipitate the silica gel with a pH control, which being a key factor in the process. The sol gel method. The sol gel process, which combines both carbon removal and silica recovery efficiently. It produces silica over 95% purity as proven by the previous research. The low temperature nature of this method helps preserve silica morphology and support green processing. Here are the various techniques are used for removal: acid leaching, chemical oxidation, thermal oxidation, and chemical treatment. The extraction of silica, the general extraction steps including combustion to obtain silica-rich ash, treating it with sodium hydroxide to form sodium silicate, precipitating the hydrochloric acid to form the silica gel, filtering, aging, and drying to obtain amorphous silica nanoparticles. This process ensures high purity and low energy consumption. The methodology of the flow chart. Here is the overall flow of our experimental process, starting with the preparation of PRHA, chemical treatment, silica extraction, and finally characterization. This flow ensures a systematic approach for accurate analysis and optimization. Experimental procedures. The experimental procedure including preparation of BRHA with a schematic diagram shows a grinding, sieving, pre-treatment with for carbon recovery, chemical extraction using sodium hydroxide, and extract, extraction of silica precipitation with acid and aging. Each step plays a critical role in achieving a high yield of pure silica while maintaining environmental impact. Here are the characterization that involved in this project. Characterization involved, which is the XRD, which used to phase analysis of the composition, SEM to study the surface morphology, XRF to identify the chemical composition, PSA to measure particle size distribution. This analysis confirmed the success of carbon removal and purity of extracted silica. The outcome that has been expected is to achieve effective carbon removal from BRHA, resulting a high purity amorphous silica. Characterization should show improved morphology, smaller particle size, and high silicon oxide content. Overall, the process aims to demonstrate a low energy, eco-friendly, and scalable method for silica recovery. In conclusion, our project demonstrates the potential of black rice ash as a sustainable raw material for producing silica. The optimized silica process enhances silica purity, reduces waste, and support environmental sustainability. This innovation not only adds value to agricultural residues but also contributes to Malaysia's green technology development. That concludes our presentation. Thank you for your attention and we welcome any questions or feedback.